Okay. So with the domain on this, we've really got two main concerns, because when we talk about functions, general stuff like when we see x squared, 3x, x cubed, stuff like that, we don't generally have issues with, okay? The two main functions that we have issue with are rational things, which is just the fancy math word for fractions, okay? Or things that have square roots in them, okay? And the reason we don't like rational things is because we can't divide by zero. So we've got to make sure that we watch out for those, divide by zero spots. The other thing is with square roots, we don't want to knowingly take ourselves into a situation where we've got i's that we're bringing in the complex number type of stuff, okay? So we're going to take a look at an example, and like I said, I'm fixing to play the toggle back and forth game, so I'm going to get this one written down over here on my whiteboard setup, and then I'll swap off. Okay, hopefully you guys can still hear me, but now the main screen should be this lovely whiteboard setup here. So when we talk about this is our fraction setup, okay? We don't really care about the top part of this because we can do zero divided by stuff. What we can't do is stuff divided by zero. So for the domain for this, we've got that x squared minus 49 is not going to be able to equal zero, okay? And we're going to solve this kind of the same way that we would with just a regular equal sign in it. So we'll start by adding the 49. Okay. So we've got x squared cannot equal 49. And then kind of same game that we've done before. We're going to take square root on both sides so we can get rid of the squared. Now, we brought in the square root, so we've got to bring in a plus and a minus with this. Square root of 49 is just nice, pretty 7. Okay. So we've got our domain is x can be whatever it wants to be, just not 7 and not negative 7. Okay. And sometimes they may list these out separately. They'll say like x can't be 7, x can't be negative 7. They may even do something like making a list type of thing. Okay. When they do this. So now, if we were doing something where we had something like, say, a square root, okay? So if I had something like, okay, for this one, we would want to say that our x plus 4 needs to stay bigger than or equal to 0, because we can take the square root of 0. Okay, that's allowed. So then we just have this, and this is just stock standard inequality, kind of like what we did way back at the beginning of semester. We would just go ahead and solve. So we would just have that our domain has to be greater than or equal to negative 4. Okay, so this would now be our domain for one like this. Okay, that would now allow that for that one. Okay, so those are kind of the two that we're really looking at when that happens. Okay, so let me get back over to here. Okay, so now the first thing that we're going to look at is just traditional combining functions. So this is just add, subtract, multiply, divide. And a lot of this is going to be just follow your nose, okay? A lot of this is just going to be kind of follow your instincts, follow your nose on what it's going to feel like, okay? When this process is through, okay? Now, add, going to feel very familiar, okay? Subtract, we are going to have to be careful with whatever this subtraction function is on the back, similar to how we saw with complex numbers, okay, gonna want to make sure that we put that g of x, that entire thing, like in a set of parentheses, and then distribute through if we need to. Multiplication is going to feel very much like either distributing or FOIL, that type of thing. Now, the big thing is on division with the quotient stuff. Now, one of the things I want you to make note of here is f of x over g of x, and they automatically say g of x cannot equal 0. It is outright whatever g of x was, it is not allowed to be equal to 0 when this process is through, okay? So what we're fixing to do, and I'm going to be bypassing, at least on the sharing screen part of this, the next 4 slides are going to ask us to take this f of x and g of x. It's the same f of x and g of x for the next 4 slides. And they're going to want us to add, subtract, multiply, and divide, okay? And they want us to talk about the domain. Now, again, when we talk about the domain, unless we create a situation where I've got fractions or square root things coming into play, because neither one of these original pieces has a square root or a fraction in it, we're not really going to have to worry with the domains too much. But we'll discuss that again more as we go through each problem. Okay, so I'm going to go ahead and get these written over here on the other side. And here we go. Okay. All right, so we've got f and g, and so they want us to do f plus g of x, okay? And guys, this is quite literally, we're just going to add them together, okay? We will clean and combine, okay, best we can, okay? So I'm gonna go ahead and put my biggest powers up in the front, so I'm gonna put my x squared up here. I've got that positive x term, and then I've got -5 and a -1, so it's going to make a -6. Okay? And that's it. Like, that is the addition one. Now, if we want to talk about the domain, this function, it's not a fraction, it's not a square root thing, so x can be anything it wants to be, all real numbers. This one over here, same setup, okay? We don't have any fractions, we don't have any square roots, so x can be anything it wants to be. When they got put together, again, there's no fractions, there's no square roots. So x can be anything it wants to be. So the domain for this is going to be all reals. Sometimes they may write out all reals, or they may even do like the negative infinity to infinity type thing if they're doing the inequality notation. Alir, did you have a question?
Yes. Is there a way to make that screen bigger? The one where you're working at?
Let me see if I can.
Thank you.
Oh, now let me try something. I'm trying to see if there's a way to make this bigger. I will try to write bigger if that will help. Will that help?
Yes. Thank you.
Okay, I'll try and write a lot bigger when I do this. Whoop, I got rid of okay, so let me start. Okay, so now they want us to do the subtraction one. So Okay, so now, because I'm subtracting the second one and there's more than one piece, okay, I am going to use a set of parentheses here to make sure that I'm subtracting all of this, okay? So now I'm going to distribute that negative. And again, same thing, we're just going to clean this up. Okay. Now for our domain, again, because this one doesn't have any problems, this one doesn't have any problems. Looking at this, also, I don't have any problems. That domain is still going to be all real numbers for that one. Okay, so now we're going to look at multiplication. Okay, so I'm going to get rid of all of this. And guys, I am going to upload, I'm going to do the little short videos in upload, but I'm also going to upload this video. Okay, so I am going to upload this one. It'll just be a little bit longer video setup. So now we're going to do multiplication. Okay. So we're going to do first one times second one. Okay. So this feels very much like FOIL, okay, and the distribute type thing. So we're going to multiply. That's going to give me x cubed. Going far side, minus x. Going that inners, I've got minus 5x squared. And then last, I'm going to get positive 5. And again, we can do a little bit of just kind of housekeeping with it, just getting kind of those powers kind of reducing as they go down. Okay. And again, domain. We haven't done any sort of, we haven't created any fractions. We haven't created any square roots. So we're still in our all reals thing. Okay. Now, the last one that we're going to have to handle, okay, is the division one. Okay, so okay. Now, oftentimes that's as pretty as it gets. Okay, but if you remember on that other part, it said g of x cannot equal 0. Well, I need to go ahead and figure out what those values are going to be. So x squared minus 1 cannot equal 0. We'll add 1. Oh, am I on mute again? Dear God. It shouldn't be.
I can hear you.
Okay. Hang on. Let's see if I can. Having to play games here. Did I come back? Can we hear me now, or I'm still on mute?
I can hear you.
Okay.
I can
Okay. I'm trying. I pray that this stuff works right when I need it to. Okay. So, Okay, so again, this, we can't let this denominator be 0. Okay, so we're gonna set it in, add the 1, kind of similar to that first one we did. Hang on, guys. Sorry. Okay, same gig. We're gonna take square root both sides, mark those off. So x can't be, again, we brought in the square root, so we bring in the plus minus. Square root of 1 is 1. Okay. Okay, so this now becomes our domain. Okay, because now we have created a fraction. So now we've got to worry about making sure this denominator thing does not equal 0. Okay, so that's kind of what our key things. Now, one other thing that could happen on the division ones, okay, just so that you're aware, and it has to do with this domain stuff that's going on. Okay, I'm gonna get rid of this. Okay. So let's say that you had something that wound up looking like this. Okay, now we can clean this up by crossing off that x plus 3 factor top and bottom. Okay, and that's going to clean up. However, the domain for this is going to be x minus 2, can't be 0, and x plus 3 can't equal 0. It's both of these. The way that it's stated at the beginning, it says the entire original denominator cannot equal 0. It doesn't say that it's like a cleaned up version or anything like that. So for something like this, I'm going to add the 2. Over here, I would subtract the 3. I've got 2 values that are off limits, even though up here with this, we can cancel those off and clean this up mathematically to something that's prettier. Okay. When this happens. Okay. So this is mathematically correct. It's prettier. It's going to be easier to work with, but both of these values are off limits. Okay. So that's just one that you may see on the division. Okay. So now, let's see if I can make this do what I want it to do now. Okay. So let me get down here. That was the subtract and the multiply and the divide one. Okay, so now the next top that we're going to look at is composition. Okay, is composite functions, and with composite functions, what we're basically doing is we're putting one function inside of another function. Okay, so the example that I'm going to do here has to do with like buying a car and the idea of like rebates and stuff. So I'm going to switch back over here real quick, and then I'll jump right back. So let's say that we were going to a car dealership and they offered 2 discounts. One of the discounts was 10% off. The second discount was $3,000 off. Okay, so now then, let's take a $20,000 vehicle, okay, and let's do our 10% off first. So 10% is going to be $2,000. Okay. And then after that, we get to have our $3,000 off. So we're left with 15,000. Okay. Now the concept is I'm taking this 10% off answer of 18,000 and I'm plugging it into this $3,000 off equation next. Okay. Now, what happens if we do them the other way? I've got $17,000. Then we're going to take our 10%. Now, 10% of this is 1,700. So I end up with 15,300. Okay. So, and it's because the discounts were done in a different order, I don't get the same type of outcome. Okay. Now, what we would like to do though, okay, is I don't want to, I mean, if we were going to sit here and go, you know, if this was pretty stock standard at the dealership, okay, then what I don't want to do is, well, I'm looking at a $20,000 car now, but then I want to go look at a $30,000 one, and then I want to look at a $22,000 one, and then maybe I'm looking at a $34,000 one and a 27. I don't want to have to sit here and run this stuff over and over and over again. What I would like to have is one equation that I could just go plug in 30, plug in 24, plug in 18, plug in 35, whatever it is, and be able to crunch it all at one time. Okay. And so that's what this composition thing is going to allow us to do. Okay. So now, notationally, what's going to happen here? Let's see if I can make this screen. Okay. So notationally, what we've got here is F, and then this is a little open circle. It's called a composition dot or a composition circle with G. Now, the first thing that's actually going to happen is if they write it to you in this notation, this F composition dot G, the first thing we're actually going to do is change it over to this F parentheses G of X notation when we do this. Now, I'm going to talk more about the domain and excluding values here in just a second when we go through a couple of the examples. But you can also do this the same way that I did the car example, where the discounts could be done. Each one could have been done first and then the other one. You can also do G out here and then F on the inside. I'm actually going to show both in the first example that I'm going to do. Okay. So I'm going to get these functions on my board. Okay. So, and they wanted us to do F composed G of X. So first thing is we trade out for this parentheses notation. Okay. Now I'm going to use some color here to help me out. G of X, I'm going to underline in red. Hopefully it looks like red to you guys. And then the first thing that we're going to do is this G of X in here is going to be replaced with what it actually is. I'm going to again use some color here. Okay. So now we are literally taking this g of x function and we're now going to plug it in f. Now I'm going to use a little bit of blocking here just to help us out. That's now my orange stapler. And so kind of sounding real stupid here. F of orange stapler is 5. You'll have to forgive me here. Orange stapler plus 6. Okay. So whatever's underneath this orange stapler is going to go underneath this orange. Okay. And again, I do the visual block here. Some students are able to see exactly how this plugin works and how it pushes in to the system. Others kind of get lost in the fact that I'm taking this whole chunk and placing it inside of another function. Okay. And again, all I did was wherever there was an X, I plugged it in. So now we're going to clean this up a bit. I'm going to distribute. So it's going to give me 10x squared minus 5x minus 5. And then I still have that plus 6 coming from the back. Cleaning up just a bit. The minus 5 and the plus 6 creates a plus 1. That's my composition. Okay. Now, even when we're talking about composition, we can still play the same games. Okay. This function didn't have any problems to start out with. This one didn't have any domain problems. When I stuck them together, my answer also didn't have any fractions or square root things. So it's also got a domain that's all reals. Okay. Now, I'm going to write this down up here. Because what I'm going to do now, and this isn't in the original PowerPoint, is I'm actually going to run this the other direction. Okay, so that was g or f of g of x. I'm now going to run this the other direction. Okay, and do the g of f of x. Okay, so same game. First thing is I'm going to switch out from that little dot to that set of parentheses. I'm going to again use some color here to help me out. Okay, so I've got f of x here in green. So I'm going to do g of okay. So now I'm going to again cover this up. I'm having to get creative here with my stuff. So now, everywhere that I see an X, I'm now going to put a set of parentheses and an orange thing. Okay, so whatever's underneath this orange goes in both of these spots. Okay, now this one is a little more involved. Okay, in it because I am going to have to do this 5x plus 6 squared. I'm going to go ahead and distribute this. Okay, now, not dealing with the 2 up the front yet. Okay. 5x and 5x is going to be 25x squared. 5x and 6 is going to give me 30. 6 and 5x is another 30. 6 and 6 is 36. And I'm going to go ahead and combine my minus 6 minus 1 to make minus 7. Okay. Now then. just so I don't have to write an extra line. That's 60x. I know that may be a little tiny to read, but it's 60x. So now I've got 2 times 25 is 50x squared. 2 times 60x is 120x. 2 times 36 is 72. Minus 5x minus 7. And then lastly, it's just doing the last little bit of combining. 120x minus 5x is 115x. 72 and minus 7 is 65. Now, the same way that we did not get the same prices on the car. We had 15,000 and then 15,300. We did not get the same answer when we did this composition the other direction. Okay. So please do not automatically think that, oh, it doesn't matter which one gets plugged in. I get the same answer both ways. You've got to pay attention to which one they're setting on the outside versus the inside so that you set it up correctly over here on this other side. Okay. Oh, I bumped over. There's another one that we're going to look at. And this one is going to have, some domain concerns. Okay, so let me find it. Okay. Okay, so they want us to do F composed G. So again, I'm going to rewrite. Okay, now this inner function, this G of X one, okay? G of X, I've already got a problem with, okay? G of X, I can't let X be 0, okay? So right off the bat, X can't be 0 because when I replace G of X with its equation, I can't plug 0 in right there. So this is now a domain thing that I've got to pay attention to, okay? So that's off limits. Now, when I get ready to plug this into this equation, okay, I'm going to have something that looks like this. Now, I still have a big old fraction right here, which means this denominator that cannot equal 0. Okay, so now we need to work on solving this one. I'm going to subtract the 2. Now, this is going to feel a little weird. I'm going to multiply that X back over to the other side. And then I'm going to divide the -2 back under. So now this is a second value that is going to be off limits. So my domain, I'm going to have 2 values that are off limits. Okay. So now with this, we just want to do a little bit of cleanup. So first thing that I'm going to do is I'm going to get a common single piece down here on the bottom. So I'm actually going to turn this into a 2/1 and multiply by an x over x. So I'm going to have 1/x plus 2x over x. And this is so that I can combine and make a single one down here. Okay, same way that you would do 1/5 plus 2/5 is 3/5. Same concept. Okay, so I have this now. this is where we go back to kind of some kind of elementary stuff. Guys, fraction bars mean division. So I'm going to rewrite this as 4 divided by this 1 plus 2x over x. Okay. Now, when you divide by a fraction, we know that it's keep, change this to multiplication, and flip that over. And then we can clean this up just a bit more. I can make that a 4 over 1 and end up with 4x over 1 plus 2x. And that is my final composition. Okay. Anytime that you start to get kind of the rational fractiony ones involved, answers do have the opportunity to get a little bit uglier. Okay. As that's processing through. Hopefully everybody's still okay. Hopefully. I realize this is not ideal at all. Okay. All right. So that was that one that we just did. All right. Now, the last thing for this section is decomposing. Okay. Now, before you go like thinking, oh my God, they're going to give me one of these like big old, you know, the 10x squared, whatever else. Now, when they do this, what you're going to look for is look for those easy break spots. Okay. The spots that will easily split over. And guys, that means if you need one of your functions, either f of x or g of x or whatever two they're using in combo here, if you need those to be like one of those needs to be like ugly, like it needs to be a big long nasty thing, then let it. Okay, like you have the option here to let one thing be kind of the nasty one and the other one be really super clean and pretty. Okay. So I'm going to get this one written over here on my other screen and then I'll switch over. So we've got h of x is x squared plus 5. Now, the key thing to make note here is what order is the composition in, okay? Meaning what is my inner function? What is my outer function when we do this, okay? And so that's going to be kind of our important gig here, okay? All right, so hopefully everybody can still see this bigger. Okay, so knowing that this is f of g of x, okay, written in our parenthesis format, guys, this would be really nice if that whole thing was just sitting up underneath the square root. And this is what I mean by let one of them be kind of that big ugly piece. Okay, I'm going to basically let one of my functions be this square root function, and the other one is going to be this orange stapler. Okay, so I just need to make sure that I figure out which one is which. Okay, so g of x is the inner one. So g of x is what's being plugged in. So that's going to be the orange stapler in this case, because that orange stapler is in the square root. So this outer function is going to be square root, and it can't just be square root. Okay, you've actually got to like put a spot on. You have to have an x there to say this is where I'm plugging in at. Okay, g of x is now what is underneath my stapler. Okay, now is that the only way to break that one up? No. Okay, there's more than one way to bust this up. There's more than one way to define what f of x and g of x are. I look for the big spots. Okay, because I could just as easily have had something Okay, that was this big old loveliness. Great. It's 1 over orange. Fine. If I'm still doing this same setup, 1 over orange, g of x is now all of this orange stuff. Okay, so g of x is now all of this big monstery thing underneath. And again, not required that that's the only way. Okay. Jenny, where'd I lose you? Okay. Are you talking about here? Okay, so what they're basically saying with this is they put 2 pieces together. Okay, so the way that we had seen the ones before where we put them together and we created this is kind of that outcome piece. And they're now asking us to kind of rip the 2 pieces back apart. But what they're not going to do is something where you would have to like refactor or anything like that. So what we do here is I take a look at, this is my inside piece. Okay, so I'm looking at up here what looks like it's inside something else. Well, this piece looks like it's inside the square root. So since g of x is inside f of x, or it's on the inside part here, then g of x is going to be this inner piece. Oops, sorry, let me get out of my blur spot. See which way I'm going to go here. Okay. Nope, that doesn't help. Thought I could get away with it. Okay, now I still have to talk about this outer function. Okay, so I still have to have this f of x, but I can't just go, oh, it's a square root. Like there's got to be a letter with this. Okay, so since I need it to just be the square root, I'm just going to need an x just to say, hey, I needed a holder there. I don't want to put anything extra with it. I don't want to put it to be a 2x or an x. I don't want to do any of that. Because if I start messing with this, like that's an x, then I got to start messing with this thing up here, okay? And we'd rather just do like the cleanest, easiest break spot that we can. Does that help? Okay, awesome. Such a y'all, I'm so not a virtual person. Okay, like y'all just don't even understand. I'm not digging on this whole like not being able to be in my classroom with my students. Like it's just okay. So let me get before y'all like start having a connection moment on the other one there. Okay, so that was 2-6. Okay. So we're going to use part of 2-6 to help us out with 2-7. Okay. Okay. So this one is going to be inverse functions. Okay. Now the inverse functions or inverse operations, first off, are just operations that undo each other. Okay, so think like add and subtract. If you take a number, pick your favorite number, add 3 to it, now take that answer and subtract 3 from it. You're right back where you started, okay? And we can do it in reverse though as well. So you can take your same starting number and subtract 3, take that answer and add 3, and you're right back where you started, okay? That's the idea of inverses, is they undo what something else did. Okay, so we've got pairs, add and subtract, multiply, divide. We've seen square and square root. Okay, so now when we talk about an inverse function, this is an entire equation that undoes another equation. Okay, now we certainly expect to see, like, if one of them adds and multiplies, I expect to see subtract and divide. Okay, I kind of expect to see those things, but we do have to be careful to make sure that things are done in the correct order. Okay, so now what we're looking to have happen here, okay, is f of g of x. So that, again, going back to that composition thing that we just had, it needs to equal x. Plain Jane vanilla x, not x squared, not 3x plus 5, not x plus 4, none of that. I need plain x. Okay, now the other thing that needs to happen is I need the reverse ordering of that composition to also give me just plain Jane vanilla x. Okay, now if both of those are true, then one of them is getting a name change. Okay, this is kind of like when me and my husband got married. Beforehand, I was Chris's girlfriend, that was Stephanie's boyfriend, that was, Chris's fiance once we got engaged, whatever else. But once we got married, in the eyes of the state, we were now legally bound together in a stronger bond than we were when we were dating. Okay, at any point in time when we were dating or even engaged, if we had separated, we would have gone on with life. Okay, but now that we're married, we are legally bound. We are bound in a different way, in a stronger way than we ever were when we were dating. Okay, now it's not that I lost any of myself or he lost any of himself. We're still our own person, but it's just how we're named. Okay, so instead of just being Stephanie Hood, that was my maiden name, I'm now Mrs. Chris Comstock. I am now linked as his wife. Okay, so that's what this middle part is right here. Okay, so what happens here is G is now the inverse of F, and instead of being called G, it just gets renamed F inverse, and that just creates that stronger bond. Okay, it now says it is bonded to F in a different way than just being this other random equation. Okay, so instead of writing F and G here, we have F inverse, and GF is F inverse F. Okay, we're going to see this more here in just a second. Okay, now the other thing to note is that the domains and range flip flop. So whatever the domain was for F, that's the range for the inverse. Whatever the range was for F is now the domain for the inverse, and that will come in handy here in just a minute. Okay, so now when we're talking about finding inverses or having them out, there's two things or two ways that we're going to do this. One of them is called verifying inverses, and this is what I call the dating method or the dating model. This is pretty much like we're just going to send, they're going to give us a couple of equations. We're going to send them out on a date, and we're going to see what happens. Okay, we're going to sort out if they work well together or not. Now, we're cutthroat when it comes to this method in math. Okay, if it doesn't work on the first round, if it doesn't work out on the first round, they're not inverses of each other. We don't go on like, oh, well, they were kind of nice and I might get, no, we're cutthroat. If it don't work, it ain't gonna work, move on with life. Okay. And the other option is what's called finding an inverse. Now I've got match.com. Guys, pick whatever. The concept here is that we are going to custom create the perfect match for these. Now, sometimes I talk about inverses being soulmates. In math, you only get one. Okay, so we're going to take a look at these in their processes. Okay, so talking about the verifying inverses. So, kind of first date, quote unquote, that you're going to get is you're going to do f of g of x. The expectation is that I want to get plain Jane vanilla x. Okay, if I get anything else, stop. They're not inverses. It's over. Okay. If they are good, okay, then you're gonna keep going. You're then going to do the composition the other direction. G of f of x. Again, you're looking to get x. If you don't get that, then they're not inverses. Stop. If both of those happen, then you're going to do a rename. Okay. So I'm going to get this next set of problems up here. And then we're going to look at what's going on with this. And I know somebody put something in the chat, and I'm going to get to it, I promise. Okay. Well, it's okay. Trust me. I'm having to hotspot this off my phone right now. Okay, like I am hotspotting all over the place. Okay, so here we go. Here's f of x, here's g of x. First round, so kind of first date, is we're going to do f of g of x. So here we go. G of x is on the inside, so we're going to plug this in. Okay, so now I'm going to write my f function, 3. When I get to the x, I'm going to put that big set of parentheses. And I got a +5 at the back. And then I'm going to bring this down. I'm going to distribute this in. Now this times 3 divide 3 against here is going to cross off or cancel out. It's going to be an x. 3 times 5 is going to give me 15 plus 5. Okay. This is close, but it's not. That plus 20 screws it up. They're not inverses. Okay. Like that's it. This is one of those, they are not inverses. We do not, I don't have to do g of f of x. This is what I'm talking about where we are like cutthroat in this. If they're not here, I don't even have to go to this. Like, I don't have to do that because it didn't work here. I don't care whether it works there because it's an all or nothing type situation. Okay. So, let me pull another example here and show you another set. Okay, so okay, so here we go. Round 1. Okay, this 4 in against that divide by 4 is going to cancel. So it's going to leave me x plus 7 minus 7. That plus 7 minus 7 is going to cancel. Sorry. Hang on. I'll make it come back. Okay. So now this is what we want. This is good. That is plain X. Nothing extra, nothing along with it. There's no numbers in front of it, nothing. That is what we are looking to have happen. Okay. So because this one's good, now we're going to go for round 2. I'm going to switch colors just because that marker's a little ragged on my side. So now we're going to do g of f of x. Okay. So we're going to plug this in. Okay. The minus 7 plus 7 here on the top will cancel off. So it's going to be a 4x over 4. The 4 and the 4 will cancel away, leaving me an x. This is good. Okay. So now what I have is these two are inverses of each other. Now, we could write this is G inverse, but traditionally we let f of x stay. So f inverse is x plus 7 over 4. Notice, I'm not changing the equation in any way. We're just changing the name because this now ties it stronger to that than when it was just the g of x. Because right now, this is like Fred and Ginger. They're just two people out in the universe. Once I have now got this, okay, these two are now soulmated together. And I now know that they are partners. Okay. Okay. That was one of the two. Okay. So now we're going to look at the other one. And this is the one that I said it was like one of the dating websites. Basically, what we're going to be doing here is we're going to custom create the equation that is going to make this work best. Okay. So the way that we're going to do this is if we have f of x, okay, we're going to change that out for the letter y. Then we're going to switch our x and y, I mean, quite literally flip-flop them. And then we're going to start to peel away the layers to get y back by itself. Okay, it's going to feel very much like peeling off layers of an onion. We just kind of have to work little bit by little bit. Once we have y back by itself, that is that perfect match. Okay, there you don't have to like check it. You don't have, you can, but you don't have to because it's been custom created for it. Okay, so this is the one we're going to do, and I'm going to get this over here on my board. Yes, I'm going to be putting this on YouTube. This one along with some breakdown videos that I have as well. Okay. So here's this one. First step is f of x is going to become a y. Okay. That marker is not dark enough. There we go. Trying to find a little bit darker color so that you can see a nice contrast here. Okay, now, next thing is we're going to switch x's and y's, and that is like literal. If it was an x, turn it into a y. If it was y, turn it into an x. Okay. Now we're going to start peeling away layers. So when we look at this, okay, the first piece that's got to go is this -3 back here at the back, because I'm, again, trying to get y back by itself. I got to start peeling away the layers. Okay. Now, next thing is I need to make this 2 go away at the front. So we're going to divide it off. Now, this is actually a time when I am not going to try and break a bunch of stuff down. I'm not going to write this as like x over 2 or 1/2 x plus 3/2. Just leave it in big, chunky pieces. Okay, it's going to make life so much simpler. Okay, now, next thing is I need to make a square root go away. So we're now going to square on both sides. This will go away. Now again, leave this in big, chunky pieces. Okay? Do not try and multiply that out and make it some big, long, thick. No. Leave it in chunks. Okay? And then lastly, I'm going to subtract 7. Okay. So now this over here, that lovely monstrosity, that is my inverse. Okay. So if I'm going to rename it, okay, and that's just, we're putting the name out in the front. Okay. It's not a big deal. Now, word of advice. Okay. This is a time when you're going to have to be super, super careful about stuff that's on top or under a fraction and what's not. Okay. What's in a set of parentheses, what's outside a set of parentheses, what's being squared, what's not. If you're going to have a square root in an answer, what's under the square root versus what's not under the square root. This is a scenario where, especially in Math Lab, you're going to have to make sure that all your little pieces are exactly where they're supposed to be, because getting something not up underneath a square root, or it's up under and it's not supposed to be up under, that is going to cause issues and be kind of frustrating to try and figure out where the mistake is, okay, when all of that is happening as that's processing, okay? So, okay, so the next thing that we're going to look at is the horizontal line test. Now, if you guys remember from kind of way back when, we talked about a vertical line test, okay? And on a vertical line test, it basically told us whether or not something was or was not a function, okay? Now, what the horizontal line test does is it tells us whether the inverse is a function. Now, I can make an inverse. We can have an inverse graph for anything, okay? It's just a matter of whether or not the inverse is also a function, okay? So please understand, if it passes the horizontal line test, the inverse is a function. If it does not pass the horizontal line test, it still has an inverse, okay? It just doesn't have an inverse that's a function, okay? And so we're going to look at how that works. We're also going to talk about how to graph inverses, and then this thing about domain restricted inverses, okay? So I'm going to draw these two graphs. You can kind of see them here. Okay. All right. So the first one that they gave us was this kind of V-shaped looking graph, okay? Now, if I take a horizontal line and I pass it over, all right, there's several places I can stop. That's just one in particular. So inverse is not a function. Okay. Now, the other graph that they gave us looks kind of like this. And we're going to, pass our line. Now, down over here, guys, this little thing is still following the same kind of taper that's going on. So this one actually is good. So okay, the inverse of this one is a function, okay? Now, let's talk about how you graph an inverse, okay? Now, earlier, we talked about on inverses that the domain and the range flip-flop. Guys, that's exactly what we do with the graphs, okay? We basically want to take our X and Y ordered pairs and we're going to switch them. So if I had an ordered pair at 2, 3, sorry, that is right in the blur, okay? Then on the inverse, it's the 0.32. It is literally flip-flop them, okay? Now, here's the deal about how we do this graphically, because guys, I don't want to have to go pick a bunch of points all over this thing, okay? So the way that we do this, and I'm going to do a separate one down here, and then I'm going to do these two, okay? Okay, is we are going to use the diagonal line y equals x. And this is a diagonal that cuts straight through quadrants 1 and 3 on a perfect, like 45, on a perfect diagonal. Now, we'll do this in a different color, okay? We basically need it to reflect, okay? So if I take a look, I'm going to start with this little loop piece right here that's underneath, and that's going to reflect like that, okay? This piece is going to reflect this way, okay? And then this piece, this green piece that's back over here, is going to reflect this way, okay? Now, it is not a turn, okay? I know with a lot of these shapes, it looks like they are rotated. It is not a rotation, okay? It is a literal switch, which is why I try to pick something where you're going to have to take a graph piece and mirror image it over the other direction, okay? So now if we go back up here to these, and I'm going to draw in that line. Okay. Guys, this piece is going to reflect this way. That's this piece. This one is on the line. So it's like touching the mirror, okay? So that red is now the inverse. Now, to double check, just so we can verify this, we said the inverse was not a function. That means on my red graph, it's not going to pass a vertical line test. Right there, it hits twice, okay? So that's just kind of proving the point. I can draw the inverse. It's there. I can make a picture. But it's not a function, okay? And we do like things that are functions, okay? We do appreciate them, okay? So for this one, I noticed that I'm getting kind of close to the line and then I'm arcing up and away. So this is going to kind of arc over and away. This is staying just off of that line, but it doesn't cross over. And so that's what that one's going to look like, okay? Again, because it's doing this taper tail over here, this is a taper. It's kind of hard to see because it does look like it goes vertical, but it is a taper tail that happens with that one. That still passes a vertical line test. Like I can hit, and again, because that's a taper tail on that edge, it does pass a vertical line test, okay? Now then, the last thing that we've got to talk about on this is domain restricted. Okay. And so the reason that they will talk about domain restricted, okay, is kind of that example that I had down here on the bottom. Okay. Okay. Is I've got something that looks like this. And right now, if I were to do the inverse of this, it's not going to be a function, okay? Because I can run a horizontal line test on it. It's going to screw up, okay? And that's what's going to happen. So what they'll do is they'll add a domain restriction and say something like, only look at this graph when x is less than or equal to 0. Well, if we're only looking at stuff less than or equal to 0, that whole piece of graph goes away. So now, when I go to do this reflection, I have that. but that's a function, okay? So oftentimes what we see them do is they will cut off parts of graphs, okay, part of an original graph, so that they have a function whose inverse is also a function, okay? And so that's why they'll go in and do domain restricted. So if they ask you to do a domain restricted, just look at the original graph, chop off the part that they don't want you to focus on, and then work on creating that reflection across that line. Okay, so hopefully that kind of processed well. Okay, now the good news is the last section, okay, because we're fixing to move to 2.8. The last section is probably the nicest one of all. If there's got to be a nice section out of the night, this is probably going to be the nice one, just because it's going to be some familiar territory, hopefully, at least a little bit. Okay. So let me get. Okay, so for this one, we're going to talk about distance, midpoints, and circles. Okay, so, and I'm going to flip my board so that I've got a grid space here because this is a little more grid spacey type stuff. Okay, now this is the distance formula. And guys, the vocabulary down here on the bottom, it's just them saying it's in words. So please don't like hyper focus on this like big definition down here at the bottom. Please don't. Okay, now, number one, I do provide you with this formula. Like when we get into a test next week, I know you don't want to hear that from me, but when we get into a test next week, I do provide you with this formula. Okay. Now, for midpoint, or sorry, excuse me, for distance, I think part of it's important to show you that you do have another option. Okay. Part of it is where this formula came from. But the other part of it is just to give you a better option. Okay. So, we're going to take a look. They want us to find the distance between, -1, -3, and 2, 3. And they ask us to put it in simplified radical. That's just where we're going to leave it with a square root on it if I need to. And then also when it is rounded to 2 decimal places. Okay. 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 Sorry. Sorry, y'all. I'm trying to figure out what I'm doing here. Okay. Sorry. See if my good space will. Let's see if this will focus. Trying to see if it'll focus on my good space. Okay, so we are at -1, -3. Okay. And we are at 2, 3. Okay. So they want us to find the distance between these 2 points. Now, I think it's important for you to understand, number one, where the formula came from, but also, again, to give you that visual way to do this another way. So the way that we do this visually is I'm going to create a triangle. Specifically, I'm going to create a right triangle. Okay. So now then, one of the options, the most obvious option for this is the one formula that we know for a triangle, for a right triangle, excuse me, is our Pythagorean theorem, which is a squared plus b squared equals c squared. Okay. We know that one. Now, here's the deal. I'm going to let that side be A and this side be B. Okay. That means the blue one over here is C. Now then, here's the deal. Y'all, I can count 1, 2, 3. That has a side length of 3. 1, 2, 3, 4, 5, 6. That has a side length of 6. And I can do a squared plus b squared equals c squared. Y'all, I can do that. Now, the whole thing of where that formula came from is another way that I could find this length is I could subtract the two x values. So I could do 2 minus -1, which is exactly this x2 minus x1. And we're going to wind up squaring that. Okay. I can count the y's, or I could have subtracted them. Now, that's a squared and b squared equals c squared, but I don't want c squared. I'm going to take a square root. Y'all, that's the formula. Okay. But again, we can do this just nice and clean and pretty with the numbers by counting. Okay. Now, I do need to take square root on both sides. Now, as far as cleaning this up, I can do that's 9 times 5. Square root of 9 is 3. Square roots of 5. And that's C. Okay. Now, if they want us to do a decimal, which this one did, okay, you have your choice. I'm going to try and bring this up to where you can see it. So I can do square root of 45. Okay, I don't have to do the simplified version, and I get 6.71. You could also, if you were, so inclined, do 3 square roots of 5, which was our simplified version. It's the same answer. So if they want a decimal, okay, and I went 2 decimal places there, I've got 6.71. Okay, so again, you can run through the formula. That's fine. You plug in your ordered pairs, but you can also do it visually, kind of geometrically, this way. Okay. Okay. Now, the next thing, okay, is midpoint. Okay. Now for midpoint, okay, this is another formula that I do give you. Okay. For midpoint, you are going to take your x's, you're going to add your x's and divide by 2, and then you're going to add your y's and divide by 2. You're basically averaging your x's and averaging your y's so that you land in the middle. Okay. Again, the verbiage down here is just saying this in vocabulary words. Okay. So we're going to take our x's, we're going to add them up and divide by 2. We're going to take our y's, we're going to add them up and divide by 2. Again, I give you this formula. Okay. So I'm going to get these ordered pairs written. Okay. So for my midpoint, x's, add them up and divide by 2. Y's, add them up and divide by 2. 1 plus 7 is 8 over 2. 2 plus -3 is -1 over 2. If you can clean them, clean them. Okay. Now, the only other way that I have seen this done, okay, is gonna be if they said this was an end and this was the midpoint. Okay. And I've seen, and if you ask it how to do this and whatever else. They are not going to say it the way that I say it. Okay. So here's the way that I do these. Okay. I'm going to stack them, end, midpoint, and then I'm going to be finding the other end down here. Now, guys, the concept here is if Tyler is the midpoint between Shreveport and Dallas, if it is 100 miles from Shreveport to Tyler, it's 100 miles from Tyler to Dallas because Tyler was the midpoint. It's the middle, exactly in the middle. Okay, so whatever it is from one end to the middle, I have to do again to get to the other end. So here's the concept. In order to get from 1 to 7, I have to add 6. In order to get to the other end, we're going to add 6 again. Give me 13. In order to get from 2 to -3, we're going to subtract 5. In order to get to the other end, you're going to do it again. So -3 minus 5 is going to be -8. Okay. So if this was an end and a midpoint, this is how you would work to find your other endpoint. Now you could also set it up into the formula and try and back solve for them, and that's perfectly acceptable too. I think this is a little bit more direct and straightforward in how it's done. Okay. So now then, next thing, and I will do this, is circles. Okay. Now, y'all, I'm not changing the definition of a circle. We aren't going to ask you to think that a circle is all of a sudden something different than it is. Okay. Because it's not. A circle is still, you have a fixed middle point and you have a radius that goes out and it builds the circle all the way around. Okay. Now there are 2 forms for our circle. The first one is what's called standard form. This is also called center radius form. What I need you to recognize here with this is that x minus h, when it's in parentheses, that is going to go the opposite of what your brain thinks it's supposed to do. Okay, now it is still your right and left. Okay, so x's is still your right and left. Think about the x-axis, it goes right and left. Okay, the y's are still your up and down, but again, it's in a set of parentheses, so it's going to do the opposite of what you think it's supposed to do. So if I see x plus 3, thinking side to side, plus we normally think goes to the right. X plus 3 actually goes to the left 3 spots. Okay. So x minus 2, normally we think minus 2 would be to the left. It's actually to the right. Okay. Same thing with the y's, that's up and down. So if I see x plus 4, normally we think plus is up. It's actually down. And if I see x minus 1, instead of thinking that it goes down 1, it actually goes up 1. Now, the other thing is that it does say r squared out there on the end. Be careful, because if they don't write it as like 4 squared, if they put it as 16, you've got to know that the radius is not 16. Okay. Now, for the general form, this x squared plus y squared plus dx plus ey plus f equals 0. We're going to see that more here in just a second when we get ready to do some stuff. So first thing it asks us to do is write the standard form of the equation of a circle whose center is at 0, -6, and whose radius is 10. Okay, now first thing is, okay, and I'm gonna just make myself a little grid space over here. I'm at 0, -6. Okay, so if I think about if that's my center, I didn't do any left or right, but I did go down 6. Okay, so when I pull this into equation, I didn't go right or left any. We're not going to leave it that way. Okay, but down 6, normally I'd go minus. It's opposite. So that's going to be plus 6 squared. And then the radius they said was 10. Okay, now I don't have to write this square. That's going to be x squared. You are going to leave this part. We're not going to like try and multiply that out. And then they're going to have that one at 100. Okay. So this is that format. Now, next one. Okay, so this is the equation that they give us. Okay, they want us to figure out where its center is, figure out what its radius is, and I'm going to go ahead and show you how to graph these as well. So again, thinking in opposites, +3 on the x's. Brain normally says pluses to the right. This actually went left 3. Y's is my up and down. Minus I would normally think is down. It actually goes up 1. Okay. So when we go to a grid space, every circle starts its life right here at the origin. So I need to go left 3, up 1. There's my center. So my center is at -3, 1. Now, my radius, please remember that this is r squared over here. Okay, so if r squared is 4, my radius is 2. Okay, so now then, if we're going to draw this, okay, now on MathLab, what you got to do is you have to spot the center, and then you have to give it one other spot on the outside edge. Okay, now don't be trying to be, fancy dancy with this and go on some sort of an angle. Go like side to side and up and down. So if you're hand drawing, you need to do all 4 of them. Okay, so I'm going to go right 2, up 2, left 2, and down 2. And there's my pretty little circle. It's a little oblong, okay? But there is basically how we do it. Now, again, on MathLab, you would have to do like this one, and then just one of those 4 dots, okay? It will auto create the circle when it creates it around, okay? So there's that one. Okay? Now, the last thing that we've got to talk about, okay, is taking our circles from their general form to this kind of graphable form. Because when they are in that x squared plus y, x squared plus y squared plus dx plus ey plus f equals 0 thing, you can't graph them. I don't know where the center is. I don't know where any of this is, okay? So the way that this is going to happen is you're going to need to get your x terms near each other. You're going to need to get the y terms near each other. And then any of the plane numbers just need to get moved over to the other side. Now, the complete the square process. And that process is discussed in depth. I do have a video on it in section 1.5. Okay. So there's a section in 1.5 that talks about completing the square. You're going to do complete the square on the x's, and then you're going to do it again on the y's. And then when we bring this all together, we've got to make sure that we bring it, both pieces into the middle. Okay. So we're going to take a look at this one. Okay. So this is the one that we're going to play with. Okay. So first thing is I'm going to regroup and get my x's near each other. I'm going to get my y's near each other. And then the 1 is going to get moved over to the other side. So now I'm going to do my complete the square process. Okay, so I'm going to start over here with my x's. So I take the number in front of the plain x and I'm going to divide it by 2. We're now going to take that number and square it. We're going to tack that on to the original stuff that I had with the x's. And then this factors nice and pretty. Now, I'm going to do the same thing with my y's. Okay. So I'm going to take the number in front of the plain y and divide it by 2. I'm going to square that value. I'm going to put it with the original parts. And then this factors nice and pretty. And again, I've got this entire process discussed in depth on the 1.5, one of those 1.5 videos. It's called Completing the Square. Okay. Now, when we come back in, I need this to look like line 3. Okay. So I've got x squared plus 4x, but I need this plus 4 that's on the end. Okay. Plus, and then I'm going to do the same thing with the y's. I need this to look like line 3. Okay. So I've got y squared minus 4y, but I need that plus 4. Now, you cannot just go adding to one side and not add to the other. Okay, so this now factors. This now factors. And I can clean this up. That's 5 and 4 makes 9. We can now discuss where the center and is and what the radius is, because looking at this went left 2, up 2, okay. It has a radius of 3. Okay, so my center is at -2, 2. I have a radius of 3. So if I had to finish this out, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. There's my lovely circle. Okay. Now, that is the end of section 2.8. So that is the end of what we needed to get through tonight. Okay. I am going to stick around. Oh, sorry. The 3 is because this is r squared. Okay, so I need to do what number squared gives me 9. Okay, we're done. Okay, I am going to stick around. If anybody wants to stick around, if you've got questions over something out of like 1.5 or 1.6, anything like that, I'm going to stick around and answer those questions. If you are kind of like, I'm good for the night, then you can log off. Like I said, I am going to upload this recording of this session. No, I'm going to reset the homework. Alyssa asked, is the homework due tonight? No, I'm going to work on getting some of those deadlines pushed out probably to Friday. Because I know there's been a whole lot of concerns over internet access, electricity, that whole thing. So I'm going to give you guys till probably Friday. I may even push it out to Saturday. And then this stuff that would normally be due on Monday, I'm probably going to push out till like Wednesday of next week. Just because we're having to play kind of some finagling games with this right now. And I don't want anybody like stressing over this idea that oh my goodness, I've got to get this all done and done like super like right now. Okay. Yes, we will still review before the test. I will still do that 45-minute time frame before the test. And that will be another opportunity to kind of go over some stuff.